All right, we're going to finish up Unit 11 by talking about some triangle congruence theorems. So the I can statement for 11.4 is I can understand, and I'm going to say it this way, side, 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 and side angle. So we're going to use an A for angle right here, side angle side congruence theorem. So we're going to talk about two congruence theorems in this section and then two congruence theorems in the next section. So to start this off, in the warm-up it says how many degrees are there on the inside of a triangle. So if we take the inside of a triangle, there are, of course, hopefully everybody remembers, 180 degrees. This is also called the triangle sum theorem. It doesn't matter what triangle you have, anywhere, anytime, any planet or whatever. If you've got a triangle, if you take those three angles on the inside of a triangle and add them together, you always get 180 degrees. So if we take a look at example B, it says find the missing example here and on C also. We've got a diagram for B. Now there are two ways to do this. Remember this little mark right here, that's the mark of a square, so that means we've got a right angle right there, so that's 90 degrees. If we wanted to add those together, we've got 130. We could take 130 and subtract it from 180. And we end up with 50 degrees. This angle right here is 50 degrees. Another way to do it is to say, look, if there's 90 degrees right here, the two of these have to have 90 degrees. So if we've got 40 degrees here, this one's got to be 50. So the answer that we're looking for, that missing angle right there, is 50. And then we'll do the same thing on this one. We've got triangle ABC, and we've got the measure of angle A. Remember, that's what that M stands for. The measure of angle A is 15 degrees. The measure of angle B is 65 degrees. If you add those together, you get 80 degrees. Well, that means that whatever's left of 180, so we take 180 and we subtract the 80. So that means we've got 100 degrees left for this one right here. Now, we've already learned about triangle similarity, and we learned that similar figures are the same shape but not the same size. So they have the same basic shape, but one's bigger or one's smaller than the other, but they are similar. The sides are proportional, as we say. The angles are congruent. But the sides are proportional. Now, proving that triangles are similar only requires to show that two of the angles are congruent. Okay, so proving that triangles are similar only requires us to show that two of the angles are congruent. All right, now, why do we only have to show that two of the angles are congruent? Why not all three? Well, if you stop and think about it, if you know you've got two triangles and you know two of the angles on each one, then you automatically know that the third one must also be congruent, okay? Let me slide that down there so that looks a little bit better. If you know that two of the angles on one triangle are congruent to two angles on the other triangle, because of this triangle sum theorem, you know, if we had two triangles where one had 40 and one had 90 and the other one had 90 and the other angle is 40, that means that last missing angle has to be 50, and it's all because of that triangle sum theorem. So if you've got two angles on a triangle, you automatically have the third one just by this process of doing a little bit of addition and subtraction. Now, proving that triangles are congruent, okay, that's different than proving that triangles are similar. Similarly, we only have to show that the angles are congruent, but when we're talking about congruent triangles, we need a little bit more information, and there are lots of different ways to do this depending on the information that we're given. So first thing we need to do is we need to figure out some of the vocabulary that we're going to use for this. So on example 1, it says, what side is included with angle A and B? So I've italicized the word included here. So we've got angle A right here and we've got angle B right here. And I'm just going to put those marks in there. Remember, that just means those two are different angles from each other. And it says what side is included between those. Well, the side that would be included between those would be the line or the segment that goes right between the two of those. So that's going to be side AB, segment AB. And then it says what angle is included with side CA or segment CA and segment BA. So let's take a look here. So segment CA, that's this one right here, and segment BA, that's this one right here. I'm going to mark those and just show that they're not congruent. We'll assume that they're not. And it says what angle is included between those. So on this one, the angle right here, and the side right here and the side right here, well, that's the angle that's created between the two of those, so that would be angle A. All right, so angle A. Now, if you've been paying attention from the context of this problem, you should probably already know what the word included means when we're talking about this geometry figure, because I've actually used it several times already. What it actually means is between. So we could have restated each one of these a different way. What side is between angle A and angle B? What side's in between those two angles? Well, side AB. what angle is between side CA and side BA. Side CA and side BA, well, that would have to be angle A. So the word included means between. So let's talk about this first congruence theorem. It's called the SSS, or we're going to say it, even though there's just the three letters, we're actually going to say the side triangle congruence theorem. And what it says is if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Remember, what we're trying to show here is congruent, not just similarity. We want to show that they're congruent. So what we're going to do here is we're going to use some transformations and some real-world examples to understand why the side theorem for triangle congruence is actually true. So take a look at A. It says these triangles look congruent, but what transformation or transformations could we do to them to make them lay on top of each other so we can match up all the congruent sides and all the congruent angles? So I've got this marked off here. Notice we've got one hatch mark here and one here, two here, two here, three here, three here. So I've got this marked out with all of the congruent sides, side, and side. So they're oriented the same way, they're flipped the right way, and all that sort of stuff. So all we would have to do to show somebody, hey, these are really congruent triangles, is we could just slide this one right on top of that one right there. Okay, so what we'd need here is just a translation. So we're going to write translation. So a translation would slide this one, triangle ABC, onto triangle RST, and they'd lie right on top of each other. Everything would correspond and match up perfectly, and they'd definitely be congruent. We could see it that way. Now, another way that we can, let me mention this. Remember, a translation is one of those transformations that is rigid. It keeps things the same size, same shape, so it does keep them congruent. A dilation wouldn't. Okay, so on B it says two identical sets of three boards each are fastened together. So see the diagram. So we've got some boards that were fastened together this way and some boards that were fastened together this way. And the set of boards that made this triangle are exactly the same as the set of boards that made this triangle. Are these two triangles different triangles, or are they just oriented differently? Well, if you stop and think about it, these were two sets of the same boards. So those two would be the same, these two would be the same, and these two would be the same. So we've kind of got our side congruence here, but more importantly than that, if these were two identical sets of the same three boards, all I'd have to do is take this one and flip it over here, and it would be oriented the same way. So I could just kind of rotate this around, flip it on top of there, and everything would be all okay. So they're just oriented differently. That's all that's happening here. So this is what makes triangular shapes so sturdy and why they're used to build things. Once three sides are set, you can only make one triangle. It doesn't matter if we flip it one way or the other. We could have one of these pointing up or something like that. It wouldn't make any difference. If you've got the same three sides, you're stuck with one single triangle. It's a very solid shape. Now, there are other shapes that don't work like this. Triangles have this unique property. So I want to show you an example on 3. So it says, think about how these boards that are, well, let's see, I should restate that. Think about how these boards are fastened together. Which shape would be stable and why? Well, if we've just got like a nail or a screw in between each one of these, you've probably all seen something like this. Maybe even the end of a cardboard box would work like this. We could basically just tip this over and we could make a shape that looks like this. Still having the same four boards putting these together, but it wouldn't be very stable. Now, if you take a look at this one right here, this triangular brace right here, make sure that this triangle right here, there's only one triangle that can be made with that. So that is completely set. So even when we attach a couple of other boards on here, it's still completely set. So which shape would be more stable? Well, this one would be more stable. So I'm just going to write stable right next to that. And the reason for that is side congruence. Once we set this down, those three boards are stuck there. They're not going to go anywhere. Okay, let's come down here and let's take a look at the next one. This one is, and I'll say it instead of the letters, this is side angle side triangle congruence theorem. So SAS stands for side angle side. And what we mean here is if two sides and the included angle, so notice we've got a side, an included angle, and then another side of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Let me just spell that the right way. Congruent. congruent. Okay, now on example 3, what I'd like to do is use some transformations that we learned about earlier in the unit to kind of show why the side angle side theorem is true. So I'm going to start off with these two triangles right here. Now they kind of look like they're congruent. Clearly they're oriented differently. And this is triangle ABC and this is triangle DEF. But what we've done here is I've slowly taken this one and I've moved it over here. So I've moved the points together. And that's getting us closer to kind of being able to see, yeah, these are actually the same triangle. These are congruent. So in order to move this over there, what we did is a translation. So we're just going to write translation. We slid this over so that those 2 points are the same. Now you're going to need to look really closely at what happened to go from this diagram to this diagram. You'll notice that in each one of these, triangle DEF kind of stays in the same place, and it's ABC that moved over here, and it's ABC that moved right here. Now you can hardly see it because here's what happened. What we did is we rotated this around right here. So D stays right where D is. C comes over here, so this would be F and C double prime, I suppose. And then B comes down here. So what we did is we made it look like this. So what we've done here is a rotation. So rotation. All right. And then this last one, what we did is we kept DEF the same, and then what we did is we've kind of flopped this over. So remember, when we moved this over here, I guess we could put A double prime is right there. So when I've moved this over, what we have is A, D are right next to each other. F and C are right next to each other, and E and B are right next to each other. So how did we go from a diagram that looked like this to a diagram that looked like this? Well, what we did is we took this and we just flipped it over. Well, when we flip it over, that's called a reflection. A reflection. We kind of used FD as a line of symmetry right here, and we just flipped that over. So we did a translation, slid those together. We did a rotation, kind of flipped this over here, rotated it over there. And then we did a reflection. We flipped this bottom triangle on top of the top triangle. And now we can see that A and D line up together, F and C line up together, and E and B line up together. So they are indeed the same. Now, one more thing I want to take a look at is take a look at angle A and D. They both have that one mark on them. A and D both have that one mark on them. D and E and A and B have one hatch mark on it. So A and B and D and E, those have one mark on them. And then, of course, this last one, CA and DF, that lies right on top of each other. That's why it's got those 2 marks there. So you'll notice that what we did here is we used 3 translations, 3 different translations, all of which are rigid transformations, so they don't change the size or the shape. So we're in good shape there. Okay, let's go ahead and, oh, the one we didn't do, of course, is a dilation, and that's why it's still congruent. Okay, let's take a look at the other side. Okay, we're on the back side of the notes for 11.4. We're on example number 4. It says, complete each congruent statement and state whether the side or the side angle side congruence theorem allows you to complete the statement. If there's not enough information to state, to make a statement, then write not enough info. So let's take a look at this one right here. Let's look carefully here. Now, there are times where there won't be all of the information given. You might have to do a little bit of thinking about this. But notice that we've got triangle JIH. So JIH is this upper triangle right here. And so what we'd like to show is we'd like to show that it's the same as this triangle down here. Now you'll notice that we have one hatch mark here and one hatch mark here. So we've got a side. And then we've got 2 hatch marks here and 2 hatch marks here. So we've got another side. What we'd like is we'd like that third side. Well, notice that they're sharing this third side. So I'm going to go ahead and mark that. HJ is congruent to itself. Sometimes we call that the reflexive property. So if we were to separate the 2 of these, we'd have a triangle that looks like this and another triangle that looks like this. These 2 sides would be exactly the same because they're kind of copies of each other. Here they're using the same line. Now, one thing that we want to do when we write down the congruence on this, the congruence statement, is we want to make sure that we write down the points in the corresponding order. We don't want to just write them willy-nilly. So on this one, it says JIH. So JIH. So one thing I like to do is I like to think, okay, so JIH. So I went from 1 hatch mark to 2 hatch marks. So we need to do the same thing on this one. So we're going to need to do H. There's 1 hatch mark and 2 hatch marks. So we're going to need to do HKJ. So we're going to do HK, HK make that look right, HKJ. And the reason we could do that is we're going to say side, side, side congruence. So here's the statement, the congruent statement that we can make, but here's why we could do that, because of side, side, side congruence. Okay, let's take a look at the next one. We've got triangle FEG, so pay attention to the order, FEG. And then over here we've got, let's see what we're matching up here. There's a side that's congruent to that side, there's an angle that's congruent to that angle, and there's a side that's congruent to that side. So this is definitely going to be side, angle, side. That's what's going to tell us that we can make those the same. And again, the order here is FEG. So we're going to go from none to 2 to the angle with the arc in it. So we're going to go from none to the side with 2 to this guy right here, the one with the arc in it. So RTS is the way we're going to need to do this, RTS. And again, this idea of writing them down in corresponding order is really important. And let me show you really quickly why. If we come over here, let's take a look at G. G is this angle right over here. It's got one arc in it. So if we come over in that corresponding spot, the third spot, this letter is S. That better be the one with one arc in it. Okay, so that's one reason why we need to write them down in corresponding order. Okay, let's take a look at example C here. It says triangle CDA is congruent to another triangle. Let's see what we've got here. And there's a little reminder here. It says you might need to remember some things about parallel lines from last year. Well, remember from last year that if we've got parallel lines, which these are, now this does not mean these are congruent. If you've got a little arrow on those, that means that they're headed in the same direction. That means they're parallel. And what we have here is we've got a little transversal cutting across right here. So what that means is this angle right here and this angle right here, those are alternate interior angles, and we know that those are congruent. All right, and then what we've got, like we had over here, we know that that side would be congruent to it on each one of these. So if we've got triangle CDA, so CDA, so we're talking about this triangle right here, do we have enough information to say that it's congruent to that one over there? Well, we're looking for either side, 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 and we've got a side. We don't know anything about these two sides other than they're parallel, and we're not sure about those right there. There are no markings on there. And remember, you've got to go by the way things are, the information that you've got, not by the way things look. So we definitely don't have side, side, side. Let's see if we can do side, angle, side. So we've got a side and an angle, side and an angle, but do we know that the two of those are congruent? Well, we really don't know that the two of those are congruent. So what we're going to have to write here is not enough info. Okay, so we can't make a congruent statement on that one right there. So let's come down and take a look at example 5. This is the end of it. For this particular set of notes, it says, state what additional information is needed to make a congruent statement based on the given theorem. So we've got diagrams on each one of these, and they've told us which theorem they want us to use, whether it's side, 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 or side, angle, side, and what other information do we need. So there's definitely some information missing here. So if we look at this one right here, these are oriented the same way. Everything looks really good. I mean, my gosh, they look like they're congruent. Notice that we've got 2 hatch marks here, 3 hatch marks here. What we'd need here for side, side, side is we would need this right here. So what we would need is that side GE would be congruent to side WY. If we had that, then we'd be all set to go. Now let's take a look at this one right here, side, angle, side. It's the same picture. What we need on this one is for side, angle, side, we would need the angle that's included between the two sides. So we would need this right here. So we would need that angle F is congruent to angle X. That's what we would need. Okay, and then on this last one, let's see, side, angle, side. Let's see here. Now again, just like we mentioned before, you might need to remember some things from previous information. Maybe that you learned last year or something. We've got two lines that cross, and they create some angles. These are called vertical angles, and what we know about vertical angles is that these two angles would be congruent. These outer ones would also be congruent, but they're not inside the triangle, so we're not going to worry about that too much. So what we have here is we have a side and we have an angle, just like we've got a side and we've got an angle. What we need is this side right here to be congruent to that side right there. So what we need is, and we'll say it this way, we need side DS side DS to be congruent to. If I say DS, I really ought to say TS down here. Those are the pieces of information that I need. All right, that's all the examples that we want to take a look at, but I do want to make you aware of some other resources that we've got here, and we're going to be using these quite a bit. So go ahead and rate yourself right here, and then I want you to take a look at, you can either click this or type this in. We're going to go to a website that's got some really cool animations and things like that. So I've gone to a website called mathopenref at mathopenreference.com. And there's a great guy, John Page. He has put together, he's a computer programmer, lives in California. He's got a whole bunch of animations, and they kind of make things nice. So the cool thing about this right here is he's got these animations where you can just drag these, and they're totally interactive. So it says drag any orange dot PQR, and the other triangle LMN will change to remain congruent to it. So I'm going to grab this one, and as we slide this over here, notice that the size of that angle Q changes, and also the other sides do that accordingly. Now the nice thing about this is that's not the only animation that he's got. He's got a whole bunch of these, and if we were to come down here, let's say we talked about side congruence. So what he's got is, he's got a little demonstration right here. So if we take this one, and we've got a side and a side and a side over here, those are the things that are set. You can mess around with those and kind of see that as you move one, if the other one has congruent sides, they also match up. And then of course there's another one. Let's do the side angle side. So side angle sides right here. And again, notice these blue marks right here. These are the parts that are congruent. So as we drag this around, notice that it's going to change the size of the angle. It's going to change the size of this side that marks up here and the one that marks up over here. And we can take these and we can move them around. And really that third side has absolutely no choice but to be congruent. Okay, good resource there. I'm going to come back over here to this. Again, do the self-assessment there, and then good luck on the assignment.